This week we're going to explore Newton's second law in a lot more detail. You might think that that's such a simple equation, F net equals ma, and you might be surprised that we can spend a whole week just looking at one equation, but you're going to find that it's a very powerful equation and it really determines the way that things accelerate. So that's what we're going to spend this whole week doing, looking at that single equation. So let's just review something real quick. I'm throwing a ball straight up in the air. We know that when the ball is at its highest point, it has a velocity equal to 0. And I want you to think about, at this highest point, think about these questions. Is the ball in dynamic equilibrium? Is the ball in static equilibrium? Is the ball not in equilibrium? Or it depends. So take a second, think about that, and then press play when you want to see the answer. Now, when you see velocity equal to 0, that might make you think, oh, that means the net force on it is equal to 0. That must mean that it's in some type of equilibrium. But that's not true. Let's just remember, equilibrium means the net force on an object is 0. If the net force on an object is 0, the acceleration has to be 0. When you throw a ball straight upwards, it's in free fall. Even when it's on the way up, it's in free fall. Even when it's at the top of its highest point, it's in free fall. On the way down, it's in free fall. The entire time the ball is in the air, it's accelerating downwards at 9.8 meters per second squared. So at its highest point, it is accelerating downwards. That means it is not in equilibrium because there is a net force on it. The net force in this case is just the force of gravity pulling down on it. Gravity is pulling down on it this entire time it's in the air. So it's not in equilibrium at any point while it's in the air. Okay, before we get more into working with Newton's second law, I just want to remind you guys that now that we are looking at forces and we're realizing how forces determine the acceleration of an object, I don't want us to forget about kinematics. Okay, remember, kinematics is the variables displacement, velocity, initial velocity, final velocity, acceleration, and change in time, and how they're all related. So if you're given a problem that gives you information about the forces acting on an object, and it's asking you to solve for a kinematic variable, such as displacement or final velocity or how long something takes, the missing link in there is Newton's second law. Meaning you can look at all the forces that are acting on the object, add them all up to determine the net force, then set the net force equal to mass times acceleration to solve for the acceleration. And then once you know the acceleration, you can use kinematics to solve for whatever other kinematic variable you're being asked to solve for. You can also go the other direction. Maybe you know something about a bunch of kinematic variables which lets you solve for the acceleration. Then you can use Newton's second law. When you know what the acceleration is, you can calculate the net force on the object. And once you know the net force on the object, that might help you get information about the other forces, the individual forces acting on the object. So let's look at an example of that. This question is asking, what is the force on the bullet? Here's some information about what happens when a handgun is shot and a bullet comes out of a handgun. So see if you can make sense of this information and see if you're able to calculate what is the force on a bullet while it is in the chamber here. And we're gonna assume that the bullet is accelerating at the same rate the entire time it's in the gun. And it's experiencing the same force the entire time that it's in the gun. And I want to know what force is that. So press pause, see if you can work on this on your own, and then press play when you're ready to go over it with me. Okay, well, first of all, what we want to do is look at what do these things mean. Okay, the mass of the bullet, sure, that makes sense. The barrel length, sure, that makes sense. That means from here to here is 0.102 meters. But specifically muzzle velocity, that is the speed that the bullet exits from the gun. So we know that the bullet is starting from a velocity of 0, and the bullet is exiting the barrel here with a velocity of 350 meters per second. So it's kind of like I know of V initial, I know of V final, I know a delta x. Those are already 3 kinematic variables where I know the values. So I can solve for a 4th kinematic variable. I could solve for delta t, how long it's in the gun, or I could solve for acceleration. Which of those do you think is going to help me figure out what is the force on the bullet? You're right, it's the acceleration. So let's do that. So I'm going to use kinematics to find the acceleration. I know my initial velocity is 0. I know my displacement is that barrel length, 0.102 meters. My final velocity is 350 meters per second, and my acceleration is what we're trying to solve for. So I'm going to choose the kinematic variable that involves the kinematic equation that involves those 4 variables. And here I've plugged in the values and I've solved for my acceleration. Now that I know my acceleration, I'm going to use Newton's second law to try to figure out what the force is on the bullet. I'm going to ignore the forces in the y direction, okay, because, sure, there's a normal force pushing up, the gun is holding it up, and there's gravity pulling down, but those forces are going to cancel because my acceleration in the y direction is 0. I'm just going to focus on the acceleration in the x direction. So I'm just going to look at what forces are acting on the bullet in the x direction. Again, I'm ignoring the normal force and the force of gravity. This is the force, that the shooting force, whatever we want to call that. It's the explosion from the gunpowder, that shooting force. This is the force that's going to make the object accelerate at this rate. So I would look at the net force in the x direction. The net force in the x direction is just that shooting force. My net force in the x direction is always equal to my mass times my acceleration in the x direction. So I can just set these two things equal. I know the mass here. I have to put my mass in kilograms. The mass was given to us in grams, but whenever we do equations in physics, the mass has to be in kilograms. And there's my acceleration that I found from this part, and then I can solve for the force that the gun is exerting on the bullet.